So to go from where we are on the periodic table to an electron configuration to an orbital diagram was kind of the question. So yeah, let's say we hypothetically we want to do oxygen, for example. So oxygen is in the second quantum level and it all the way into the p orbitals over here. So oxygen is atomic number 8. That means we have to have 8 electrons. So 1s2, that orbital is full. I can only hold 2 electrons. That takes me here to helium. Okay, 2s2, that takes me to beryllium. Now to get to oxygen, I want to have 1, 2, 3, 4 electrons. So 2p4 takes me to oxygen. And I know that because anytime I'm working through this region in the periodic table, I'm filling my p orbitals. I have 3 p orbitals, 6 electrons total. So we've got 4 of those electrons. Now for the electron configuration as seen in the orbital diagram, just to write this out in the orbital diagram, right? 1, 2, and 3. So here is my 1s orbital, my 2s orbital, and then my 3 2p orbitals. So that electron configuration, we always want our electrons. And remember, I draw a little half arrow to equal 1 electron. We always want our electrons to be spin opposed. So I have 2 electrons to assign. I'm going to put 1 up, 1 down. I've assigned both of those electrons. They're pointed the opposite direction, so they're spin opposed. 2s2, same thing. 1, 2. Both of those electrons are assigned. Now we have to assign those 4 electrons in the p orbital. We're going to go through and do the same thing, except for we need to make sure that each orbital contains an electron before we pair up those electrons. So 1, 2, 3. Now I can go back and I can pair up an electron for that 4th electron that oxygen has as a valence electron in the p orbitals. So that would be my orbital diagram for oxygen. 1s2, 2s2, 2p4. I get that from the periodic table, and then when I fill in those electrons in the orbitals, right, I would just go and make sure each orbital has 1 electron before I go back and pair up those electrons.
So the number on top, the 4 are the electrons, right?
The number of electrons, correct. Yep.
And then the circles, you have 5 circles. So are the 5 circles from the the 2, 4, like the 1s, the 2s, and the 2p. So you added those numbers together to get 5 circles?
No. So each circle represents an orbital.
Okay.
So good question. Each circle represents an orbital. I have 1 s orbital. So this circle right here, this is showing my s orbital. I have 1 s orbital at the second energy level. So there's that orbital right there. And then I have 3 p orbitals at the second energy level. So 1, 2, 3. These 3 circles represent, each one represents 1 of the p orbitals that I have. I have 3 p orbitals total. So we could go and do, something else in the periodic table. We could do chlorine, and we can kind of see some of the similarities here, for example. So if we do chlorine, right, to get to chlorine, we need 17 electrons, and we're in the 3rd quantum level. So 1s2, 2s2, 2p6 takes me to neon. Now I'm going to start in the 3rd quantum level. 3s2 takes me from sodium to magnesium, and then 3p 1, 2, 3, 4, and 5 takes me to chlorine. So 3p5. That would be the electron configuration. We could also write the condensed configuration of this. Right, the condensed configuration, we would use the nearest noble gas, the nearest complete noble gas, which is neon. So we could replace this by simply saying, I have the electron configuration of neon, followed by 3s2, 3p5. And then to fill out that orbital diagram, the orbital diagram, here's my 1s orbital. Here's the other s orbital I have at the second quantum level. Here are my 3p orbitals at the second quantum level. Now I would go to the third quantum level. At the third quantum level, there is my one single s orbital. And then I'm still at the third quantum level, but I'm dealing with p orbitals again. There are my 3 p orbitals that I have at the third quantum level. To fill in those electrons, just like we did before, 1, 2, that one's full. 1, 2, and here are those 2 electrons. Here are those 2 electrons. Now I have 6 electrons. So 1, 2, 3, 4, 5, and 6. And then my 3s2. So 1, 2, and that one's full. 3p5, do the same thing. 1, 2, 3. Now I go back and double up 4 and 5 to finish the electron configuration, the orbital diagram of chlorine. So yes, each of those circles represents an orbital. I only have, at each energy level, I only have one s orbital. At each energy level from 2 and up, I have 3 separate p orbitals. And then at the third energy level, I start having access to d orbitals. And at the fourth energy level, I would have access to the f orbitals. But that's in general what we would do. And that's what these little circles represent. Each circle represents an orbital. This is the 1s orbital. This is the 2s orbital. I have 3 p orbitals. So 1, 2, 3. Each circle represents one of those p orbitals, right? There's a different direction for each of those. It's px and py and pz for those orbitals.
I get it now.